All right, let's dive in. So we've got some interesting situations that happen with number lines. So I'm going to pass out your notes, but I want you guys to think about this situation. It tells us that Juan lives 2.5 blocks from Amy. Michelle lives 3 3/4 blocks from Juan, but the only reference point that we have is Amy's house. So you can partner up with somebody close to you. I want you guys to try to figure out where are the possible locations for Juan's house and where are the possible locations for Michelle's house. Can anyone figure out how many possible locations there would be for Michelle's house? That is not a question I want answered right this moment. It's a question to ponder. So think about, would Juan be east or west? Take my mouse back, please. Distance is never negative. So when we get told 2.5 blocks, that doesn't tell us what direction we're going. It just tells us how far. So when we're told 2.5 blocks, there's options. So go ahead, partner up, whatever. I'll give you guys like a minute, maybe a little bit more than that. Try to figure out the possible locations for Juan and for Michelle. So the sound effects are unnecessary. We're in middle school. Okay, gravity works. The stapler's heavier than I anticipated.
Gravity check.
All right. It's okay if you're still working, but I'm curious, does anybody have Juan's possible locations? Ooh, lots and lots of hands. Saul, start us out.
Do I just say where Juan lives?
Yeah, so like when you started thinking about this, what was your thought process?
To find 2 and go in the middle.
To go to 2 and go in the middle. So which way did you go, positive or negative?
Positive.
Positive, so you went to 2, and then in the middle of there for half, so that'd be about 2.5 right there. So this could be Juan's house, right? So this is Amy's, so we don't know who lives here, but then we're saying Juan might be that 2-story house. Now, was that the only location that his house could be? No. Elena.
His house could also be at like -2.5.
Yeah, this is not directional, so this could be east or west. And when we think about that, we're thinking positive or negative. So his house could also be at -2.5. Now be careful. We had this on one of your homeworks, and I saw that people were struggling with the negative partial values. Remember, if you're going to -2.5, you have to go to -2 and then keep going negative. Some people would have said that -2.5 was here. That is wrong. That's -1.5. So be careful. We have to go continue that direction. So Juan could live here. So now what we see is Juan has 2 possible locations. How many possible locations, Marissa, will Michelle have?
4, and they are positive 1.25.
1.25. So now I can erase that and say this might be Michelle.
Okay, positive 6.25.
So probably that last house there.
Negative 1.25.
-1.25.
Negative 6.25.
And that's, yeah, we probably go here. Does anyone have any questions or does anyone disagree with that? Now the question is, how did she get all those locations? Dom, do you want to talk us through?
Well, because 3 3/4 blocks, so that means for each possible Juan location, there would be 2 answers because there's no negative distances. So she could be either east or west.
Yeah, so from this Juan location, she went the east possibility 3 3/4, and then she went the west possibility 3 3/4. Then from this possible Juan location, we can go the west option, and we can go the east option. And that's how I find my 4 different locations. Does anybody have any questions on this? Jeremiah?
Can we actually find out which house she lives in by
Nope.
doing this? No, because
Unless we find out more information. So there's this famous riddle from, and maybe I'll print it, but there's this famous riddle that talks about who lives in what house, and it's talking about a street. And it's describing this person likes this, and this person drinks this, and this person drives that, and like, so it's this big long riddle, but there's one key piece of information that ties it all together. So maybe if we knew that Michelle lived west of Juan or something like that would start to give us some more information, but right now, we can't figure it out. We're stuck. Any other questions about this? Essentially, what we've been told would be a really good way if you didn't want your friend to be able to find your house. You'd be like, oh, we'll start at Amy's house, and then go 2.5 blocks to get to Juan's house. Then from Juan's house, go 3 3/4 of a block to get to my house. And then the person actually starts trying to do it, and then they're like, oh, crap, they don't like me. You know, like if somebody gave you those directions, those are terrible directions. You're never going to find that house. So try this. I want you to plot all locations possible. Paul lives 1 3/4 blocks east of Michelle. Now we have a little bit more information. What are the coordinates of Paul's house? So now we got mad at Amy or whoever told us the directions. Now we figured out Amy lives in the middle, Michelle lives just to the left, and Juan lives to the right. So this matches up with our possible locations that we had. Look at our original Amy, one of our Michelle possibilities, and one of our Juan possibilities. That's where we found out they now live. So we figured out those 3 friends. Now we got to figure out where Paul lives.
I know where Paul lives.
Who can tell me how we can remember the direction? That's why I'm asking that. Who can tell me how we remember the directions on a compass? There's lots of little memory tricks. Acadia?
Never eat soggy waffles. Dang.
So we can do my little like T that people have to make, and there's almost always an arrow at the top. That top is going to be our north, and then going around in a clockwise fashion, never eat soggy waffles. You could also say never eat sour watermelon.
Yeah.
What else? Sean?
Never enter Santa's workshop.
Never enter Santa's workshop. Anyone know any other ones?
Never eat soggy wheat.
Never eat soggy what?
Wheat.
Wheat?
Yeah.
Well, I don't know. It's hard to keep those, what's that cereal with the little, like, wheat things? Those mini wheats, yeah, they get soggy, like, immediately. Sam?
My brother's name is Sean Wortman, so does never eat Sean Wortman.
Yeah, I would agree with that one. So, I always refer back to the never enter Santa's workshop, because that would be a bad thing. So, north, south, east, west, that is how you can remember the directions of a compass. North and south are your verticals, east and west are your horizontals. So if we're told that Paul lives east of Michelle, on my number line, that direction would be positive or negative? Positive direction, right? So start at Michelle's house and go 1 3/4. Now wait a minute. This is negative 1 1/4. The easy way to do this is do your partial, then do your whole. And I say that, well, I mean, you could do it the other way, but the reason I do my partial is 3/4, right? So if I do 3/4, here's 1/4, and then 2/4 is really what a half. So I do my half or my 2/4, then I do my 1, and I get jumped to here. So I land at a half, which makes sense because this is positive, this is negative. What's the difference between them? 1 3/4, 1 1/4. They're 2/4 different, or a half. So that tells me that Paul lives here.
No, he lives with Amy.
very close to that point. So maybe they should have said 2 blocks east, but 2 would have been too easy. So we're saying that Paul is right here.
I said that, but I wasn't sure. He either lived in that house, he was homeless, or he lived with Amy. One of the two. Well, I mean, one of the
Or like right between. There's like some
An
shed.
apartment complex.
or if
So-
he lived up a full box.
So now we're being asked to write an equation. Now somebody last week reminded us, what's the difference between an expression and an equation? Evie, we haven't talked yet today.
An expression is like you don't solve it, it's just there. And then an equation has an equation sign and then you solve it.
Yeah, an expression will involve some kind of operation. An equation has to involve an equal sign. So it says, write an equation that expresses variation from normal in terms of recorded temperature and normal temperature. Use your equation to complete the table. So we want to represent variation relative to recorded temperature and normal. So recorded is what the temperature was or like is today. Normal temp. Anyone ever watch the news? Like, do you actually watch the news?
No.
Yeah, I mean, 7th grade, not many of you, like, I don't expect very many of you. But a lot of times they'll say the normal temp for this kind of year. Now, what do they mean by normal? How do you figure out a normal temp? There's actually another word that we could use to substitute that. Monica?
Average.
Average. So they take like the last 10 years or 50 years or 100 years and they add them all up and divide by how many years they were looking at. And then that gives them the average temperature. So all the really, really highs and really, really lows, they kind of balance each other out and you get this normal temp. So if we want to talk about the variation, what do you consider variation? If you consider something has variation, what does that mean? What does it mean when something has variation? Dom?
Is it sort of like variation reminds me of like variable, so it's like kind of different or like the difference between them?
Yeah, it's different compared to what?
The average.
Compared to like the normal, right? So we could say, let's right above here say that variation, let's represent that as V. Our variation will be V, and maybe you need to, my paper probably needs moved a little bit to do that. Normal, variation. So our variation, let's say normal can be N, and recorded, let's say R. Makes sense to just use the first letters of each word. So how are we going to find variation? What is variation going to equal? So if we say V would equal, Dom just told us what a variation is. Andrew?
Would it be the difference between recorded and normal?
Now, do I do recorded minus normal or normal minus recorded? Dom?
Couldn't it be like it would be recorded minus normal? Because
Okay, so if I do recorded minus normal, then I have negative 35 minus a negative 4. I get a negative answer for my variation.
Well, for the first one it'd be that, but isn't it after that? Wouldn't it be opinion?
So think back to the lesson from Friday. Just like distances have to be positive, differences or variation we would want to talk about as like a positive number, I would think.
And crack the Vinci's code.
Because look at this. My high is 41, my normal is 15, so that's a positive. I need to figure out this one. Maybe our variation can be negative. If our variation is allowed to be negative, would it be recorded minus normal or normal minus recorded? Honest?
Why are you trying to minus? Shouldn't you just add the negative 35, negative 4, and then divide it by 2?
Well, and then you have
I think you're reading the table wrong.
Yes.
So this is one situation, this is one situation, and this is one situation. We're not relating vertically, we're relating horizontally. So we're talking about the high temperature in January was 41, like the highest recorded temperature. The normal high temperature was 15. So the variation from normal was 26. So the question is, did we do 41 minus 15 or 15 minus 41? Sam?
41 minus 15.
41 minus 15, so it has to be recorded minus normal, right? So we can get rid of this second option. So if I do recorded minus normal here, to find this value, I'm going to have to do negative 35 minus a negative 4. Now, how in the world do I do minus a negative, Sean?
Well, you did 34. Yeah.
My bad. Good catch. How do I do minus a negative?
Plus a positive.
Sean?
Negative, yeah.
So I'm pairing up. They have to be right beside each other. So negative 35 now plus 4. They are different signs. So we take the stronger sign, find the difference. I get negative 31. That my variation. Now what would that tell me by my answer being a negative 31? Because does that actually mean it was a negative amount of different? Like, can the difference be negative? No. So what does the negative actually represent here? Like, what does that tell me? Dom?
If it was cold.
Well, yeah, but so that means that my recorded temperature compared to my normal, how? How did my recorded compare to my normal? My recorded was what compared to my normal?
31 degrees.
It was lower, right? That negative is telling me that it was different.
Custodian to the office, please. Custodian to the office.
But I want to know, what was it different as in higher or was it different as in lower? Because guys, that makes a huge change in what we're communicating. If we say, hey, the low temp in January was 31 degrees off of what it normally is. Well, if it was 31 degrees higher, everything would be melting. Like, that's a dramatic, 31 degrees is a huge change. 31 degrees lower than the normal, well, okay, I mean, everything stays frozen. You might have a couple extra snow days. Might be a good thing. So now if I say that my variation is 4.2 and my normal is negative 4.4, if this is a positive number, what would that mean about my recorded temperature? Is it going to be higher than this temp or lower than that temp?
Lower.
If the variation is positive, that means that my temperature is higher than normal, right? So if this one was lower, that means that this one will be higher. So to do that, what we're really finding now is our recorded temperature.
I don't get it. I don't get how you said that if one is lower, one is higher.
So this one has a negative sign on it, right? My variation was negative because when I did the math, I got a negative 31. So that told me that my temperature, my recorded, because the variation was negative, my recorded temperature has to be lower because this negative, I can't go a negative distance, right? I can't go a negative amount of degrees, but I can go an amount of degrees in the negative direction, which just makes my temperature lower. So if my normal temp was here and I know that my difference is 31, well, positive 31 would take my temperature higher. Negative 31 takes my temperature lower. So this variation being a positive variation means that wherever my normal temp is, if my variation's positive, I go up from that normal temp. Does that make sense? Since the variation's positive, I'm going to go up.
Negative 31 is lower. We know that the recorded temperature is lower than the variation.
Yeah, by 31 degrees. It's lower by 31 degrees.
1 by 31.
Because this is the difference between them. It's the variation between them.
Ah.
That's not a temperature. That's an amount of change. Okay? So if this is 4.2 higher, then I'm going to have to take my negative 4.4 and do what with that 4.2? Jeremiah, question or answer?
It was an answer.
Okay.
I was gonna say I know what the answer.
What do you get?
I got 8.6.
Ooh, you went the wrong way. Nope. This is why I was asking this question. So, what we really want to do here is take a step back and look at something that's going to lead us to our next chapter. I'm looking for the recorded temperature, right? That's the box I'm trying to fill in. So what I'm looking for is R. Now you guys hopefully have done a little bit of work with equations maybe. If I have R minus N, how do I get R by itself? I want to figure out how do I find R. Jeremiah.
Okay, isn't it? Oh, it fell down.
I know, it just took me a second to think. How would I get R by itself there?
Is it V minus N or V plus N?
Well, what do you do to undo a minus N?
Add.
So we're going to get into our equation problem solving or equation solving. Anytime you want to isolate something, figure out how to get rid of whatever else is happening. To get rid of a minus N, we can add N. And I get that R will actually be the variation plus the normal. Or I can flip this around and say it's the normal plus the variation.
Why?
So what I see here is my recorded will be the normal plus the variation. My normal is a negative 4.4. My variation is a 4.2. Do those have the same sign or different signs? Different. So which sign's more powerful, the positive or the negative? The negative. And then what's the difference between them? Anyone?
8 points. Oh wait, no.
Remember, we're finding the difference between them.
2.2.
It's just 0.2, just 2/10.
Why do you have the plus n? Because when you do plus n, don't you like remove it over there?
What do you mean, why do I have the plus n? Where?
R equals n plus.
So, addition, right? Addition is commutative. 2 plus 3 is the same thing as 3 plus 2. I can change the order of addition and it doesn't change the problem.
Yeah, but don't you do a plus n right there to
Here?
the below?
Right here. That's to get rid of the minus n. That, like, you don't have to really understand this yet. We haven't done much with equations yet. But if I start with an equation that has v by itself, but then I want the equation to have r by itself, I have to do something to that equation to get r by itself. So we start with v equals r minus n. And I'm trying to get r by itself.
So you do plus n.
So when I do negative n plus n, these cancel. But when I add n over here, that doesn't cancel. That changes what I see on that side, and I get
Why
that
do you
r
add n over there?
because I can't just do it on one side.
Oh.
If I just do it on one side, I've broken a mathematical rule. I've made my equation uneven. Because if you have, like, let's say you're standing on a balance. Like, have you seen a balance before? And you're balanced with another one of your peers, and you're both holding 5 bowling balls. And I go and I remove a bowling ball from one side of the scale, but I don't do anything to the other side. Is the scale still going to be even? No, because I didn't keep it even. Now, if I remove a bowling ball from both sides, my scale stays even. That's why I added the n to both sides. I can't just add something to one side, but when I do it over here, these cancel. And my left side just becomes v plus n, or n plus v, order doesn't matter.
Equals r.
Equals my r, which is now isolated. I could also up here isolate the n, it would just be a bit harder. But that's in our equation solving that we're not quite there yet. I just wanted you to understand what math we were doing and why we were doing it. Any other questions? I don't know why that didn't capture the equation. That's odd. There we go. So here's our equation. R minus n, right? R recorded minus R normal. If v is negative 2.6 and n is 5.3, how do we solve for r? Well, we already isolated our r, so you can either use this equation or you can use our equation, but for our purposes and to understand this whole work with equations, let's use their original equation. So go ahead and fill in, we have negative 2.6 for my v. My n is 5.3, but I don't know my r. So r minus my n is 5.3.
Negative.
My v is negative, my n is not.
Shouldn't that be an R? I mean V
What?
instead of an R?
So here's what I'm replacing. V equals r minus n.
Okay.
So my v is negative 2.6. That replaces right here. My n is 5.3. It replaces right here. My r and my minus, nothing happens to them. Any questions? So, I need to solve for my r. Right now, I have an equal situation. Negative 2.6 is equal to r minus 5.3. So if I do something to one side, I have to do it to the other side to keep things even. Honestly.
You do plus 5.3 on both sides.
Why?
Because then you take away the 5.3 and have something equals R, and that's you get R.
You're right, but I'm taking away the subtraction of 5.3. So be careful with how we think about this. You're right to get R by itself. Right now, when we ask ourselves what's happening to R, it's being subtracted by 5.3. We don't want that to happen. Stop messing with R. So we need to stop this from happening. We do the inverse operation. You're going to hear this a bunch. Inverse operation, we're going to add 5.3, but I can't do it only on one side. I have to do it on both sides. Any questions with why I just did that? I would on your paper show that these, the minus 5.3 and the plus 5.3, equals 0. Yeah, Jeremiah?
We did this in 6th grade, and we would do it. Our teacher would have us do a upside down, like capital T, and then when we were doing the problem.
Yeah, so you probably set it up something, I don't know if this would be dotted or something
Yeah,
like that. You can if you want. This, I don't really love the equals bar, and the reason I don't is because a lot of times once we get deep into this, we'll be doing multiple steps to isolate something. Whitney?
Why don't you make the 5.3 negative and then add 5.3?
So I didn't make the 5.3 negative. This was minus, and it stayed minus, stayed minus. When I plugged in 5.3, I plugged in a positive, but it was already subtracting n. My equation tells me it's r minus n. So this isn't negative, that's a minus. But to undo subtraction, I have to add. So that's, I'm adding because this is subtracting, not because it's negative. Does that make sense? Yeah, that is a minus. That's a really good question, so I'm glad you asked that. That is a minus. Any other questions with just what I've done up here? So now, what we would see, I don't know if you want a squiggly line or something, R, if I were to look at what R equals, now I'm flipping around the order of my equation, I'm putting R first, because it's easier to look at. I have negative 2.6 plus 5.3. I'm going to write this out just to look at it. Negative 2.6 plus 5.3. Honestly?
2.7.
So how? I never just want the answer. Please be careful with that because I assumed you had a question. I hadn't yet asked for the answer. So don't just shout out the answer ever, like anybody, unless I just say, what's the answer? We're looking for the process to get there. When you just say the answer, it ruins that for everybody else who's still solving it. Does that make sense? Okay. So explain the process.
Okay, so from 5.3, if you take 2.6 to minus, cancel out.
We're not adding. Or sorry, we're not subtracting, we're adding.
Yeah, but okay. So you from 5.3 you take away 2.6 to get the difference.
But why? You're not explaining.
I don't know.
You're just telling me what to do, but you're not telling me why. I'm not saying you're wrong. You're just not telling me why to do what you want me to do.
Because
This is not subtraction yet. I could make it subtraction. I don't need to. I could, but you have to explain how to get there.
okay.
Or we do it like addition.
Okay. You can do it. I don't understand how
Now, you're still going to do it. I'm just going to coach you.
I don't understand how to make
In the addition way of looking at this, first question we always ask ourselves when we look at addition: are my signs
The same.
the same or different? Are my signs the same or different, Marissa? Different. This is getting to what you kept trying to tell me to do. So because my signs are different, the next question I have to ask myself is,
which has the greater value.
which sign has more power? Which one does?
Positive.
The positive. So I bring down in my answer space the positive. Then
You find the difference.
I find the difference. I have to do the process before we get there. So then I can do 5.3 minus 2.6. I got to borrow here. Be careful with your subtraction. 13 minus 6, 7. 4 minus 2, 2. I plug it in right here. I get a positive 2.7. Please make sure you get this process written down so you understand it. Are there any questions? Are there any questions? Solomon, you got this all written down? So if I do an open notes test and you don't have these things written down and I give you the same problem, you're probably going to kick yourself for not writing this down. So my firm advice is if I write it on the board, you're writing it on your notes. You guys never know when you're going to walk into a mastery and I'm going to say, get your notes out. You can use your notes on this. And if you were lazy taking notes, you're just going to do a whole lot more work later when you have to revise and redo your tests and do extra assignments and do more work on the front end to make your life easier on the long run. So now we've got two vocab words. Range and interquartile range. So the interquartile range, that's a really big word. Let's forget about that for a minute. Range. When we talk about range, anyone have a drone? Yeah, we put a drone up in the tree. We barely got it out. We got it out though. So drones and remote control cars and those sorts of things have a range. What's a range in that situation? Andrew?
The range of how far the signal you transmit to make it move.
Like how far the signal can transmit, right? So that would be the distance, what?
Between, the distance from the 2 points.
Yeah, the distance between like you, the controller, and the device, right? The drone or the remote control car or whatever. So range here, on your notes, please write range. We're going to write out a definition. How would we define range? Dom?
The distance between 2 points A and B.
Yeah, but what if I have more than 2 points? What if I have like 10 points? What if I have like the numbers 2, 9, 7, -4, 13, 326, -42, and 0?
The distance
Call 'em out.
between multiple.
Calm out? I don't know how to calm out, man. Whitney?
The distance between the highest and lowest.
The distance between the highest and the lowest, or the maximum and the minimum, or instead of saying distance between,
Difference.
I can just say difference. Difference between max and min. The distance between the maximum point, or the greatest value, and the minimum point, or the lowest value. Now, interquartile range is really weird. Now, quartile. We've got this word quartile. What does quart mean? Andrew? 4. So we break our data up into fourths. So if you've ever seen a box and whisker plot, we've got our range definitions. I'm going to go ahead and erase this. If you've ever seen a box and whisker plot, you'll see that we have these points right here. We've got a point here, and then here, and here, and here, and then here. But what you'll actually see, and what I'd like you to notate on your box and whisker, 1, 2, 3, 4. A box and whisker plot has just broken up your data. You got a question, Andrew?
Just talking about
Is this something we might enjoy hearing? Like, if you know something, I'd love to hear it. This has broken up the data into 25% chunks. This is 1/4 of all of the data. This is 1/4 of all of the data. This is 1/4 of all of the data. And this is 1/4 of all of the data. So if I asked you where are most of your values concentrated, or where are most of your numbers at, Jeremiah, what would you say? Yeah.
You said where were they most be concentrated at?
Yeah.
They would be all spread out.
Nope. There's a point of extreme concentration here. Every time I look at you, you're looking down, not up here, so I can't tell if you're paying attention or not. But if you, let's say you have 20 data points, and I break it up into fourths. How many data points are in each chunk? If you have 20 data points, how many are in each chunk, Julian?
5.
5, right? So there'd be 5 data points in between these 2 dots, 5 data points in between these 2 dots, 5 data points in between these 2 dots, and 5 data points in between these 2 dots. So my highest point of concentration, where most of my data is, Katia?
It would be in between. It would be in the 3 sections.
Yeah. Most of my data, 25% of my data, a fourth of everything, is between, what, like 6 and 8 maybe? Right between. And here is 25% of my data, but it's all really spread out. Here's 25% of my data, all spread out. But if 25% isn't here, that's where I'm really concentrated. So that would tell me that most of my results, or the highest concentration, falls into that section.
Why is it concentrated in the smallest and not the biggest?
So this is yards gained on the first quarter plays. Who plays football? So can you lose yards on your play?
Yes.
Yeah. So negative yards gained would be losing yards. This means 25% of the time they lost between 15 and 10 yards. Another 25% of the time they either lost, like they were between losing 10 yards and gaining 6. 25% of the time they gained between 6 and 8. And then 25% of the time they gained between 8 and 23 yards.
So why is
That means that the highest they ever gained was 23 yards.
So why isn't it 4 and not? Why is it 3 and not 4?
What do you mean?
You said the most concentrated point is 4 to 3. Why isn't it 4?
So say if they ran 20 plays, like we just said, 5 of the plays would be in here. 5 of their plays would be in here. 5 of their plays are in here. And look at how little amount of space there is to fit them in. So that means that 5 of the data points that we have are all crammed into there. They're all really close. When we talk about concentration, that's numbers close together. So there's the same amount of plays out here, but they're more spread out, so they're not as concentrated. So I'm running out of time, so I got to get through this. IQR is the distance or the difference between, so I guess I'll say difference between. Yeah, E-R-E-N-C-E. Distance between Q1 and Q3. Now wait, what are Q1 and Q3? Would be the next question in your head, I'm sure. Ellie?
Quartile 1 and quartile 3.
Yeah. Quartile 1 and quartile 3, which are really below it if you want to write edges of the box.
Wait.
So your quartiles, this edge right here is quartile 1, and this edge right here is called quartile 3. So really your interquartile range is the distance between the edges of the box.
Then can it be between any of the
Well, so this is your first quarter, second quarter, third quarter, fourth quarter, like breaking up my data into quarter. Hey guys, we're not done. I still have 2 minutes of teachable time, and I'm gonna give you a couple more things. So please don't pack up until I tell you to. All that'll make me do is get your notes back out and then waste time into your next class, which is rude. So here, if I go back to looking at range of my data, my range would be the distance between the whole thing. So if we say that this is negative 15, and let's say that this is 23, it'd be 23 minus a negative 15. So actually my range here is 38. But my interquartile range is just from quartile 3, which we said was 8, minus the negative 10. So my interquartile range is only 18. So that tells me that 50% of my plays are in this range within 18 of each other. But if I look at all of my plays, they're spread out among 38 is their range. Questions? Yeah?
Can it also be like between quartile 1 and 2? Or
No.
Why?
Because our interquartile range is strictly looking at the center 50% of data. So we don't look at this whisker and we don't look at that whisker. So we're getting rid of the edge 25% and only looking at the middle. That's why you can't shift it and say look from there to there. It doesn't do the same thing. We have to look at the middle 50% of the
But
data.
what if that middle line was...
That just tells you exactly where the middle data point is.
So from there, 25% on each side, the 15%...
So here's 25%, there's 25%, 25%, 25%.
So it's always Q1 and Q3.
Yep. So it's really Q3 minus Q1. We'll talk more about this tomorrow, and we will do a little bit of review. Our mastery will be on Friday, so we'll go ahead and start the next chapter before we do that mastery. So we'll wrap up this got it problem tomorrow. We'll set this all up and do a box and whisker. Thank you guys very much. Have a wonderful day.
Mr. Hudson.
Yes, sir.
Can I grab my water bottle?
Yes.